In the name of Allah. Hello guys. In this video we are going to model the suspensions footbridge in OpenSees as a two-dimensional modeling. You see guys, in here we have two types of this suspensions bridge, and with definitions of the elements properties and section properties. For example, in here we're going to define the three types of cables: area, and defining the mass at each nodes of these cable structures, and then definitions of the 204 degree of freedoms for these two-dimensional modeling of these cable structures, and running three types of analysis: pushover analysis, free vibration analysis, and dynamic analysis. So we're going to model these two types of bridges and run these three types of analysis and seeing the result. So for this dynamic analysis, we're going to apply the horizontal and vertical seismic accelerations, and for the pushover analysis, we're going to have an incremental displacement of this node, and then free vibration analysis also we're going to apply the displacement in this coordinate, and then seeing that this response spectrum of this result of these cables structures. So we're going to model these two types of cable bridge in OpenSees. So first of all, let's see the explanations of the pushover analysis. So before seeing the OpenSees code, let's see the outputted data. So see guys, in here we're going to see the different results of these two types of cable suspensions footbridge result. So in the first example of the pushover analysis, we're going to apply the displacement in here, and then seeing the result of the deformed shape of these two types of structures, and also base reactions and displacement of these two types of structures. So you see, by changing the cable geometry of these structures, the result is different, and also the shape of the formation of these structures is completely different. See this deformed shape of these structures and also these structures. So it's different, and also base reactions and displacement as a pushover result. So let's see the OpenSees file of this pushover analysis. You see guys, in here I defined two different OpenSees file, and these codes are available in my GitHub, and you can download it and change it with your own. So in the first example, like this, I defined many functions, and I recommend you guys to read these websites to better understanding of the modeling of these cable structures. And you see, I defined many functions. Guys, these functions and also these functions must be used just for one time, because if you want to delete the last data as output data, you can just run it one time to delete all outputted data, and also this one to generating the data's file directory. And let's see, I defined many functions for plotting and outputting the data, and also checking the analysis for better converge. See guys in here. So in the OpenSees cable suspensions bridge 1 file, in here you can see the pushover analyzing output. So we're going to define the linear or non-linear definitions of the cables, materials properties, the length of the cable, the height of the cables, and also arc tip. It means these values, h1 L as the length of the cable, and also arc tip, I mean these values, and also different cables areas for these three types of cables, I mean these values as the definitions of these three types of cables areas, and also defining the geometry of the nodes of these cables structures, and also fixing the these cables at the start and the end of each cables as a boundary condition, and also definition of the material properties. So you can change in this code and change your own material properties. So if the linear is true, so we're going to define these properties, and if it's false, we're going to define these properties for the definition of the nonlinearity of the cables, and also definition of the cord truss for better simulating the cross behavior, the cable behavior, and also defining the pushover properties, and then outputting the displacement and base reactions for these structures. And in each step, you see guys, in each step we are going to output the different shape of these structures, and then trying to record it and then plot it at the end of the structures outputted data. So this pushover functions is going to be shown, and then in here we're going to define the materials and structural properties, and then run it these pushover functions. You see guys in here. After 89 seconds, the outputted pushover result is going to be calculated and shown in here. And as I told you, the result of this pushover analysis, it's going to be shown. So let's see the other shape of this suspensions footbridge. I mean this shape, and all the properties is the same guys, but in here the geometry is different. So we're going to define the different nodes coordinate for these kind of structures, and all parameters such as boundary conditions, material properties, section properties, and also analyze properties is the same. See guys, just these cables structures geometry is different. So we're going to define the h1 and h2, and also bridge length, and also arc width of these structures, and these properties as a cables areas is the same as this one, and let's see the result of this outputted data. You see the different shape deformations of this pushover analysis outputted data. So in free vibration analysis, we are going to apply the initial displacement in this coordinate and also this coordinate, and also defining the mass at each node, and the initial displacement for this cable structures is 2 millimeters. So we're going to run the free vibration analysis, and after the free vibrations, it's going to be stopped. So the form shape of this two types of analysis going to be shown in here as a damped vibrations and undamped vibrations. So you see the form shape of these two types of cable structure is completely different. See this shape? It's like an W shape, and also base reactions and displacements of these damped vibrations, and also undamped vibrations of this free vibration analysis going to be shown in here as a base reactions and displacement, and also in horizontal and vertical directions. So let's see the OpenSees file of this free vibrations analysis of these two types of bridges. So for free vibration analysis of this foot suspensions bridge, we're going to define the free vibration analysis functions with definitions of the damping and damping ratios, definitions of the linear or nonlinear behavior, durations, and total mass of these cables, and also initial displacement, length of bridge and height of bridge, and also arc depth, and also different material properties of these bridges. And in here we're going to define the mass in each node, because we want to run the free vibration analysis. It's very needed, and also material properties is the same as last analysis. And see guys, in here we're going to run the free vibration analysis as this middle node as a y directions, and then running the dynamic analysis with Newmark method, and with definition of damping on or undamping models, we're going to output the data at each step. And then for better plotting the time history, I defined the functions in here. You see in here the codes are available in my GitHub, and you can change it with your own data. So all the structural properties is the same, and you see guys, I defined 51 nodes for each cable's structures. You can change it and increase it or decrease it for better for your modeling, and also definition of the initial displacement and damping ratios, and also durations of the analysis. And for this undamped and damped analysis structures, outputted data, you see guys, it's going to be run, and after 8 seconds the analysis is going to be outputted as a time history, vibration analysis of the damped and or undamped structures for these structures as a displacement of in x and y directions, and also velocity, accelerations, and also base reaction in x and y directions, and also last an initial deformed shape of these structures, and also base reactions in x and y directions, guys, for damped and undamped structures. And also use the histogram for better seeing the these outputted data. For example, the histogram data of the displacement has this shape for undamped and damped structures, and also displacement in y directions histogram. So let's see the third analysis as a dynamic analysis of these two types of structures result. So in dynamic analysis of this suspensions bridge, we're going to apply the seismic accelerations in x and y directions, and by definition of the mass in each node of these cable structures, we're going to run the dynamic analysis and then outputting the data. So after running the analysis, the last outputted deformed shape of the structures is going to be shown in here, and also time history of the displacement and other outputted data such as displacement in x and y, velocity, accelerations, and also base reactions in x and y directions for undamped and damped structures going to be shown in here. And also for this type of cable structure, it's going to be shown in here for undamped and damped structures. And you see the deformed shape of these two types of cable structures is different, and you see by changing the geometry of these cable structures, we can change the different behavior of the response of these structures during the dynamic analysis, or even other outputted analysis data. And you see, guys, base reactions and displacements of this dynamic analysis with x and y accelerations is going to be shown in here for damped and undamped structures in x and y directions. So it is the x directions outputted data, and it is the y directions outputted data for these two types of structures. And also I'm gonna show you the histogram of this outputted data for displacement in x and y directions for undamped and damped structures, and also acceleration velocity for these two types of structures going to be shown in here, and also base reactions for x and y directions. See, guys, for example, velocity for these structures has this shape of this histogram, and also for other structures has this shape. And also let's see, you see the accelerations has this shape, and also acceleration of this structure has this shape, and base reactions probability distributions functions of this histogram in y direction has this shape, and also these structures has this shape. So you can see the different shape of the histogram, and you can manage it your model to better predicting the next behavior of the structures based on these materials, or even applying loads factors. So let's see the OpenSees file of this dynamic analysis. So in OpenSees cable suspension bridge 1 dynamic analysis, we're going to define the dynamic functions. Materials properties is the same as last analysis. Geometry is the same. All parameters is the same. But in here we're going to define the seismic accelerations parameters in x and y directions, and also outputting the base reactions, acceleration, velocity, and displacement of this middle node of the structures in x and y directions, guys. So for better understanding of the modeling of this suspension bridge, I model these structures as a two-dimensional modeling. You can change it for three-dimensional modeling, and seeing the different response of these structures during the, for example, wind loading. And you see, I defined the applied time history for outputting the data of this structure's response. And in here we're going to define the dynamic analysis properties, damping ratios, durations, times of these seismic accelerations. So seismic acceleration is 10 seconds, but the analysis duration is 50 seconds, guys. And we're going to run the undamped and damped structures and outputting the data. See, guys, after about 11 seconds the analysis is going to stop for this dynamic analysis, then outputting the different shape of this displacement in x and y direction, velocity, accelerations, and base reaction in x and y directions, and also seeing the base reaction and displacement in x and y directions, as I told you before, for each step. And also for better understanding the histogram and also displacement distributions of this structure response, I use the histogram, and you can see the different shape of this histogram for better understanding the structural behavior during the dynamic analysis during the seismic accelerations. This helps us so much. Let's see the other structures OpenSees file. So in OpenSees cable suspension bridge 2, the dynamic analysis functions for this structure is going to be shown in here, and definition of the dynamic analysis functions with these properties. All the material section properties is the same, and also acceleration is the same, but geometry is different. So geometry is different, and we're going to output it the velocity, accelerations, and displacement, and base reactions, and each step we're going to output the different shape of the structures as a displacement. And also in here we're going to plot the histograms time history outputted data as a function, and in here we're going to run the dynamic analysis, and you see with different shape and of these structures with total mass durations and damping ratios. We're going to run these two types of undamped and damped structures. Guys, this code is available in my GitHub, and you can download it and change it with your own data. So my target is to show you how can we model these cable structures in OpenSees, and I don't use very complex methods, definitions of the different material properties or even section properties for this increasing this complexity of this modeling of this cable suspension bridge. So my target just for educational purpose of modeling, and you see the base reaction and displacement for this second suspension bridge in x and y directions, the form, shape, and initial values, and also the histogram for different outputted data for velocity, acceleration, displacement, and so on. My target for preparing this kind of videos is just educational purpose, guys, and nothing more. I'm gonna show you very simple modeling of this cable suspensions bridge in OpenSees. Please have a comment or even email me to tell me about this kind of modeling. God bless you guys. Bye.